It's that time of week again. Sunday, 6 p.m. Welcome to Steve's Place. And I have some important news for people, about our conference, which is coming up in August 7th to 11th. We are going to do a live stream on the conference. If you want to find out more information, click on the code on the corner screen there, and that will take you right to the live stream sign up sheet or information sheet from which you can sign up. Or you can go to teslatech.live and they'll have more information there. And this year's conference is promising to be a really good conference. We have over 25 speakers there, and we have excellent hotel rates, $84 a night, and that includes food. And every evening we're going to have something there for people to eat while they talk to their favorite speaker. You know, so like I said, again, the QR for the live stream is on the right hand corner there. You can click on that; it'll take you right to the website. You come back to it. I'll put it up at the end too. Anyway, and those who want to sign up and still get 20% off, call me at 520-463-1994 after the show or tomorrow, and we'll get you in there. I can't emphasize, you can hold the hotel and get your registration made immediately if you even think about going, because these rooms are going to be cut off from us here in a couple of days. So please sign up, register at the hotel, uh, I'll get your reservation at the hotel for the conference. Register. We got 20% discount here, and we're looking forward to seeing you there. I know we have a great lineup, and I think everyone's going to have a great time. And also, if you haven't subscribed to our YouTube channel, please do so. Subscriptions are free. We have a couple hundred videos there that you can watch for free. And if you want to be supportive of us, you can go to join for $9.99 a month. It helps keep us alive. It helps us enable us to keep finding the DVDs, to keep putting them up there. I put another one up there today, as a matter of fact, on anti-gravity. So anyway, go to teslatech.info and use our conference directory, speaker directory, or just the overall channel. Okay, again, on the right-hand corner is our live stream QR if you're interested in a live stream. And I know everyone's going to have a great time if you do go to the conference. Oh, and don't forget, if you like our show tonight, be sure to give us that thumbs up, in the bottom of the YouTube thing to help the search engines find us. And like I said, this conference is going to be quite the conference. We have quite a few speakers, especially on things like water. And George Weissman will be there on Thursday. You won't want to miss him. It's a rare opportunity to get to meet him, Robert Slovak, and Krishna, who was on our show the other day. And then on Saturday night, we're going to have a special guest, Greg Braden, with John Peterson, to give us some information about the future events here. And we're going to kick the whole show off with everything electric and electric universe. And one of the things we're going to be talking about is the Star in a Jar, which is a program which was to take and create a miniature sun on a tabletop. And anyway, we'll have information on that. I can't emphasize, don't miss this conference. You never can tell. Life is too short. And the only regrets I've had is the ones I didn't take advantage of. So, without further ado, I'm going to introduce Jeremiah Ferwerda. He's come to us from Spokane Valley, Washington, and he's done a lot of work on the Tesla turbine. And I'll just let him go ahead and explain it all. And welcome aboard there, Jeremiah.
Hello, thank you. Hello, everyone.
And so tell us a little bit about yourself.
Excuse me?
Tell us a little bit about yourself.
Oh, okay. I'm in Spokane Valley right now. I've been working on the Tesla Turbine project for probably 5 years. or about 5 years. And it's basically everything's been leading up to the point that we're at right now. I just finished the bill of materials for the new production turbine. So the turbines will be available at myteslapower.com soon. I don't have an exact date for that yet, but we're a lot closer than we've ever been. Yeah, it's the thermodynamic transformer. That's basically what it does. It takes a heat reservoir or any heat source and turns it into electricity. If you have a high enough heat thermal difference, you can use a thermal difference. The lower the temperature difference, the lower the thermal temperature difference, the less power you can get from it. But you can get power all the way down to 40 degree Celsius difference, or less than a 40 degree Celsius difference. But the practical power comes in at about 40 degrees Celsius temperature difference. So let's see. Let me see if I covered everything there. Oh yeah, solar collectors. You can get the heat from solar collectors. Solar heat collectors are closer to 90% efficient, as opposed to as opposed to photovoltaic cells, which are only about 15 to 20% efficient. So with solar heat tubes, if you have enough of them, you can actually heat your house with solar heat tubes. And then with the turbine, because you have the heat difference created by the solar heat tubes, you can produce electricity while you heat your house as a side effect. So let's see, normal panels. You can use anything that burns to produce your heat. So a lot of people have wood gas generators that they use to produce electricity for their off-grid home. And those tend to be really complex. They get dirty and they're difficult to clean. There's a lot of corrosive aspects to it that makes it so that you have to replace your parts or get like stainless steel, very expensive parts to build the system. So with my system, all you have to do is hook a heat exchanger up to your wood stove and you got heat. You don't have to make special pellets or anything like that. Geothermal, that would be applicable to people in like Norway. There's other countries, and even around here, there's in Spokane or around the Spokane area, there are hot springs that could be used. In Idaho, there's hot springs where I used to live that somebody came to me and asked me if it would work for producing electricity. It definitely would have at the time, but it hasn't been ready until now. So, oh yeah, ocean surface to subsurface temperature differential. There's a potential to make electricity there as well. How does this all work? Well, basically, you've got a hot side and a cold side. There's water. There's usually water in both sides, and you take a vacuum pump, and you only need to do this once if there's no air in the I mean, if there's no leaks in the system. You vacuum all the air, it's CO2, nitrogen, oxygen, and other gases that the air that we breathe is made up of. You have to pull all of that out of the system, and what happens is the water that was compressed now has a chance to vaporize because there's no air pressure preventing it from vaporizing. So once your system is full of water vapor, you have these two, the evaporating water and the liquid nitrogen. You don't actually need liquid nitrogen. That's just for illustration. You just need you actually only need a small temperature difference for the air, for the water to vaporize from one side and then condense in the other side. So as long as one side's cooler than the other, you'll have a flow of gas going between the two from one side to the other. It's called a cryophorus. And so that's the visualization of what I was just saying. One side's warm, one side's cool. And you put the turbine in between, as illustrated here, and then the gas flows from the low pressure boiler or the water battery. It's now not a water battery, it's a thermal reservoir is what I'm calling it now, because you don't necessarily want a large tank. You don't necessarily want a large tank full of water that you're heating up, because if you want to heat it up to a higher temperature, you don't want to build up any water pressure. So what we got now is a heat exchanger inside the low pressure boiler water battery. If you just imagine a heat exchanger inside of that tank, and then the actual tank could be dirt or concrete or sand, any medium. You heat it up, and then you get a thermal reservoir that holds that thermal energy in. If it's insulated, at any point when we've got a sensor that will sense the battery's voltage, when your battery, or you can use a small battery bank to smooth out the power from the turbine, because it can be the power comes in a little bit choppy. So you have that battery smooth out the power. When that battery is sensed low, the valve opens and it automatically charges those batteries up. And then you have a power inverter that's converting that DC into AC, usable AC. So it goes from AC off the turbine generator to DC with a bridge rectifier, charge controller charges your batteries with that DC. And then you can use the power with an inverter at 120 volt AC to run your house. And all you need is a low temperature differential. And then once that water condenses in the condenser, you pump it back to your boiler or your heat exchanger in your heat reservoir, and the cycle continues. So you don't have to continuously use more water. Usually with a steam system, they have to either continuously use the water that they use to boil and create steam, or they have to have a condensing tower, and you can lose a lot of power condensing your water that way. So yeah, this is showing how you can use the solar heat tubes, which are upwards of 90% efficient, to heat your heat reservoir. And it says low pressure boiler, but that's actually the heat reservoir, to run your turbine. And then anything that burns, you can also use. It shows that little flame that popped up at the bottom under the boiler there. You can also use anything that burns. And typically what someone would use is just their wood stove, firewood. When there's no sun in the wintertime and you still want electricity, like my dad, for example, he's got a wood stove and he's constantly running it already in his house in the winter time. He could be getting electricity as a side effect, or as a direct result of just burning his wood. You can also use your existing solar panels, solar voltaic solar panels to heat your reservoir. So the point here is all these different types of heat sources can power the turbine. And you can be creative and think of anything else. Like, even if you had a generator, you could harvest some heat from that generator and use that as electricity as well. So let's talk about some of the advantages of the Tesla turbine over other turbines. They nearly last forever. They're the most robust turbine in existence. They scale better, which is contrary to popular belief. the performance augments with size. So this actually does work very well on a large scale, even though that's not what they tell you on YouTube when you search that in on Google or YouTube. They say, oh, well, it's not used for large production turbines because it's impossible to get the disks to go fast enough for it to be efficient, which is just completely wrong. If you type in Tesla turbine, the video with the most amount of views on the Tesla turbine on YouTube will give you some really bad math at the end, explaining why that can't work. I might explain that later. The design is the most simple. So a small scale turbines scale, or turbines, when they're smaller, they're less efficient because of the surface area that increases dramatically when you increase with size. But with a smaller turbine, you have less surface area to deal with, and you have more turbulence, higher speeds, and with the Tesla turbine, because it's laminar flow, you don't have to worry about those issues on a smaller scale turbine. So also, you don't have to clean the gases before you use them to run the turbine. So there's a lot less parts than like a regular just generator in general. Manufacturing cost is exponentially cheaper, and that's the only way that we're able to get this into production with a small budget, is because the manufacturing costs are exponentially cheaper, and it's the most efficient turbine in the world, basically. Yeah, this is why they last longer. They use viscosity. They operate on the principle of viscosity and adhesion instead of impact. They're more efficient due to laminar flow and can operate at much greater velocities without destroying the rotor. So with a regular turbine system like this, you have to perfectly clean the gas before it enters into the turbine, because if there's any contaminants whatsoever in that gas, you have high-speed gases and particles impacting the rotor, and that will tear it apart. So if you want to build a turbine system like this, the complex geometries of the rotors and the processes that you have to go through to clean the gases make it just impractical. And the low efficiencies with the smaller turbines just make it impractical for systems like the system that we've built. Velocity is important because it takes less torque, which the Tesla turbine actually has a lot of torque. Just nobody runs it with the right temperatures and the right gases and the right pressures to be able to see that high torque. But there is no lack. We found out just recently there's no lack in torque on the Tesla turbine, which is contrary to popular belief. So the faster you run the turbine, the less torque you need, and the less pressure you need on the inlet. And the more efficient you can extract that energy. So myteslapower.com is my website. That's my email address. I got my Patreon there. And then you can visit me on YouTube. Just search in Tesla turbine or my name. So after this presentation, now that we've seen the presentation, I want to show our latest video that shows where we're at now. So these 5 years I've been working on getting the turbine to this point. In this video, we don't have it completely running by itself yet, but we are very close. We're getting a controller that will control the the valve and the entire system. I've basically got the entire system automated, but we're making a single board where you can just plug everything into and it automatically runs the turbine system. So my next videos that I'll be showing is me plugging something into the power inverter and getting electricity out and running power tools and all kinds of other things just on my thermal reservoir being heated. So let's go ahead and watch this video.
All those bulbs are hooked up?
And we got the inverter charging the batteries.
Okay.
When it turns on, when it gets to 150 volts, the inverter will kick on and it will add load up to whatever the batteries want to draw.
What is it, ballpark, like 400 or 500 watts or something?
It's about 500 watts at that speed, but we're going to be drawing a lot more power now.
Yeah.
These are all rated for 120 volt.
Yeah.
And our volts are going to be a lot higher than that. So this is going to drag the generator down a lot. Like,
okay.
maximum.
Well, we'll see what happens. So how many watts of bulbs?
In series, then the voltage
Yeah.
will get up a little
Yeah.
higher, and then we can get more wattage.
So in parallel, what is how many watts is that?
They're all in parallel. It's 3,200 watts
Of bulbs?
of bulbs.
So they probably won't light very bright.
At these speeds, I don't
Yeah.
think we can even get close to powering that.
Yeah. So they'll be
If we go
dim.
faster, we definitely could
Yeah.
power that.
But we might as well try it out since, you know,
Yeah.
why waste the heat?
Right.
Pressure are we up there? PSI gauge.
50 psi.
There's a massive amount of heat right there.
We need to power some shit.
So you feel comfortable kicking it on?
Well, yeah.
But you're just going to feather it. I mean, well.
I'm just gonna go on off and then let it wait a minute.
Okay. So, okay. I don't know ultimately what's going to happen.
Fine. I think it's gonna be okay.
I don't know ultimately what's going to happen, but no matter what, this is for you, Paul.
Are you ready?
Okay.
Seems to be working good. Working all right.
Okay. Still recording. Whoa!
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 That's freaking awesome! That's amazing! Charging at 500 watts.
What is that, about 70% bright at the peak?
70% of what?
Are those bulbs about 70% bright at the peak? Like
Yeah, probably.
maybe 70? What is that, about 70% bright at the peak?
70% of what?
Are those bulbs about 70% bright at the peak? Like
Yeah, probably.
maybe 70? So 7 times 3, 21, 24 plus 7, it's almost 3,000 watts.
Yeah.
70% plus 500 watts. We're almost 3,000 watts, and we're just screwing around.
With the
Well,
500 watt load on the.
yeah. So total, it's almost 3,000 watts.
Yeah. And it's because
What's the freaking?
the speed we're only going up to 14,000 still. It's just adding more load. So imagine at 35,000 how much power you could get out of this thing. That's what.
Okay, so I was so excited because I didn't expect the power output to be that high at those lower RPMs, because I was always getting power, like most of the highest power outputs was always happening at those higher speeds. So for me to get that power at only 16 or 14,000 RPM, I was really shocked. So, I mean, we hit a threshold where we increased the temperature just a little bit more than we usually did. We usually ran the tests at, and the power output was just exponentially higher. So this is what we've been building up to for this whole time, is to put this turbine into production so that at least we can use our wood stove. I mean, that was the whole point of my project to begin with, was my dad wanted to use his wood stove, and me including me, to power the house with, or to assist his solar system. But it can do much more than just power your house on your wood stove. You can use multiple types of different heat sources to heat your thermal battery, which is just mass. So also I wanted to note that this system, we call it a thermal battery or a thermal reservoir. With storing heat energy as heat instead of in chemical batteries, for the same price, you can literally store hundreds of times more power in mass. So this can definitely replace traditional batteries or chemical batteries, which are polluting the planet. They're expensive to make. You have to replace them all the time. So, and you can also heat your home on the solar heat tubes, which is the primary source, is the primary intended source of heat for running the turbine. And this is also the turbine itself and the system as it is now is very useful. But what we want to do is the sales that we make from selling the turbine that we have right now, there's a couple small changes that we're going to make to the system to bring up the thermal efficiency and make it even better. So pushing this turbine and the system to the next level is what we'll be doing next. But for now, you have a turbine that can run on a wood stove, electricity source from a wood stove or a rocket wood stove, or solar thermal heat tubes that you can also heat your house with. And yeah, that's that. Steve? Oh, there you are.
Yeah, I'm back. So I'd like to make a couple comments here about the Tesla turbine. It is the only turbine in the world that can run on a solid fuel. And they've done things in California that Jeff Hayes sent me a report on, where they actually ran a Tesla turbine using sawdust, the sawmills there. You know, you can't do that with any other kind of turbine because it would simply eat up the rotors, And then if you use sawdust, then you use powdered coal, for instance, as a fuel, and get rid of the boiler and just run it directly if you wanted to. I've had in my magazine a hybrid system where they're using the Geet turbine, or not the Geet turbine, the Geet reactor there, and using the gas to feed the Tesla turbine, and you're able to get the basically a pollution-free burn out of it. You can
also make steam from the extra heat from the generator as well, and feed that in with the exhaust through a Venturi nozzle. And that's the kind of thing I'm talking about when I say we still got some R&D to do to make the system better. So the turbine that we're going to be selling is going to be adaptable to all these new ways that we're going to come out with to run it in the future to make it even better. So, but what you got to start with is a balanced, high-speed, quiet, smooth-running turbine that can be used in all these different types of situations, and that's what we've been working on.
And Jeremiah, have you guys worked on this as a pump at all, or just been strictly as a turbine, as an engine?
Oh, well, that's part of the plan. We need to incorporate the pump, which is like basically phase 2 of the system. I've already got the drawings finished for the pump. We're going to be building a pump soon. There's also, I can't talk too much about it right now, very soon though, heating and cooling with the turbine straight off your solar panels for like a heat pump. So even if you didn't want to hook up the entire rest of the system, it's very simple just to run the pump as for heat pumping, for heating your house and cooling your house on many times less power than it would make it practical for heating and cooling your house on solar, which is unheard of. So yeah, that's a lot of R&D. Not a lot of R&D because it's so simple compared to the main system that I've already built. But I mean, we got a lot of innovations coming right up after this turbine.
So on this turbine, are you running your house on it yet, or?
No, but I'll be demonstrating running the shop tools and stuff at our shop on it. I'll be. Now, we don't have enough space at the shop to put the solar heat tubes up. So right now what we're doing is we're just heating it with the heating element plugged into the wall. And it's just because it's in a small location. I mean, it's in our shop. We don't have a lot of space, and we're renting the shop, so we can't set everything up, practically. So we're just simulating a heat source. And like I said, it can run on all these different heat sources. So the temperature going in. I mean, what we're also going to hook it up to a rocket wood stove. That's going to be really easy to do here at the shop, or here at my shop. It's going to be really easy, and it won't take up much space to hook up just a little rocket wood stove and show people, hey, we got a little rocket wood stove, we got a little bit of firewood. Now we have electricity to power our house and to heat our house or whatever,
Well, here's a question for you from Amakar. Gonzalez. When you talk about the gases, it reminds me of air purification. So could this be another side benefit of this device?
Yeah, I can see how that could be used for air purification. Could definitely be used for water purification, and that's basically I'm making distilled water when I run my turbine. Right now, I'm distilling water, and you can also distill water with ambient heat temperature differentials, which is amazing. So you can get distilled water for basically, for a very small fraction of the electricity that it takes. Actually, you can get electricity by distilling your water, but I've got iron pipes in my system right now because it's cheaper, so it's got rust, and you wouldn't want to drink this distilled water. But in a system intended for making distilled water, or at least purifying the water, it wouldn't have to be 100% distilled for drinking and stuff. You could get clean water from dirty water by running it through the turbine.
Well, a couple of years ago,
generating electricity.
When Johnny went and visited you in Salt Lake, you were mixing it with ammonia.
Yeah, I wanted to use a different gas than water because you have lower boiling points. But the problem was I was testing turbines that I wasn't completely designing. So I just had to test with what I had, and I know that it would have worked very well if I had the turbine that I'm using right now. But I know that testing never went through with that stuff. So that we definitely want to test with other gases, but water works great for now, and that we're definitely going to test with other gases. I don't think I would choose ammonia just because it seems like it likes to attack all the metals. If I had an iron casing, which we might build, then I could use ammonia. But there's other coolants out there that usually they use in refrigeration systems that we could use for testing. And I also want to test with rubbing alcohol or with ethanol, because that has a lower boiling point than water. So for generating electricity, water really isn't the best gas to use, or steam, but it works really well. So
Okay.
for our intended purpose.
Here's another question. Jeremiah, what do you think about using iron? Paint it black, set out in the sun to collect heat. Specifically, half-inch thick iron sheets wide enough to catch a lot of sunlight. Paint it black with a special paint to collect a lot of heat.
Well, you definitely could collect a lot of heat. If you had enough surface area, that would be practical. The temperatures are much lower that you could collect. So you want to get a reasonable temperature difference, unless you just have unlimited heat coming out of it. If you have enough surface area, then yeah, you could definitely do something like that. But the solar heat tubes are just so much, they're already refined, and there's a vacuum surrounding the tube, and it's a glass tube, so you end up getting way more power from the sun if you use those solar heat tubes. So I'd recommend those solar heat tubes unless you have an enormous volume or an enormous area that you could collect your heat from. And that would also require testing to see how much area you would actually need. So the lower the temperature difference, the less efficiency you get and the less power you get. So you really want to try to get that temperature difference up there. Now, there is something that we're going to be doing that can decrease that temperature difference requirement and increase the thermal efficiency with low temperature differentials. And that's kind of proprietary at the moment right now, but it involves a pump. I can say that. And that's something that I've always intended on using with the turbine, but I had to make it more simple, and I had to start with the turbine. I had to perfect the turbine and get it working, get the system working, so that we can continue our R&D, because the R&D is pretty expensive. But my skills over the years have gotten exponentially better, like my CAD drawing and my knowledge of the thermodynamics through this whole experience has exponentially grown. So the rate that we do our R&D now is exponentially faster. So we're not going to have to wait 5 years for that improved system to use those lower thermal differentials. One, because we're going to have the funding from the sales of the turbine, and two, because of all of my skills have been refined.
Well, I'm pretty interested in the pump also. Back in the 80s, I had a friend, he was one of the original Tuskegee airmen, and he made a test of turbine about the size of your fist, and he used it for pumping water, and it could pump just about as much water with that as these huge pumper trucks could do with the fire department.
I recently built a pump, not for steam and gas like what we want to use it for, but I built a little water pump for our boat, for our little airboat, and I was powering it with a drill, and it was amazing how long I could troll around it with that little pump. I might have a YouTube video of that on soon, but I do want to make some improvements to it. But yeah, this is very, very powerful. It takes very little electricity to pump a lot of water.
Yeah, and it seemed to me that there'd be a real market up there, where you have all those forest fires, that if anyone had a stream and a little pump like that, they could probably save their property,
Yeah.
But I was really impressed with that.
They're way more. It's a centrifugal pump, basically, and you don't have all that cavitation. What little cavitation you do have it's not going to destroy your pump. So you can run it at higher speeds, and you can make smaller pumps, centrifugal pumps that run at higher speed that don't have too much cavitation, because it's all laminar flow. So yeah, the efficiency and the power of pumping water, Tesla pumps pumping water is ridiculous.
And the thing is, if it was big enough, and your hose is big enough, you could just drop this thing into a creek or a stream and not have to worry about picking up any sediment, destroying your pump. We'll just continue pumping. Very versatile. There's a company down in San Diego or El Cajon, last I heard, and they were building these pumps, but they don't like referring to them as Tesla pumps. I think they're trying to keep some kind of proprietary stuff or patentable stuff, but
yeah, they probably want to keep people away from reading the patent, the original patent.
So, so they are getting somewhat used. I mean, some of the things, like pumping.
And the military used them.
Pumping biological.
Pumping oil and stuff. One of the things that they found out was that they put a little mark on the disc, some kind of marker. They wanted to see how long that mark would be worn off, to indicate the life of the pump. And I think it was a month. And then they opened the turbine back up and looked at it, and the mark was still there. So that indicated there was basically zero wear on the pump. So they were pumping particles in the oil too.
Well, here you go. Does a solar heat tube focus the sunlight, being glass and all?
Well, no, it doesn't focus it down into a focal point like you normally would do. Although you can put a reflector on behind the tubes, but they just directly absorb the sun's heat. That if you type in solar heat tube on Google, you'll see. You can read all about them. They're getting cheaper too, because you have to buy them from the right place. There's a lot of places that you can buy them, and they're a lot more expensive. But if you look around, you can find them for a better price.
Well, when I was in college, ancient history, one of the big problems with solar cells is they get destroyed by heat. And with the 115 degree heat we're getting almost on a daily basis in Las Vegas these days, these solar cells are taking a heating. And what you have to do is they have to cool them, usually with some kind of capillary system behind the solar cell array, to cool that heat away. Now that would be perfect heat that we could scavenge, with the Tesla turbine and produce even more power.
Yeah, and that solar panels are like 15 to 20% efficient. The reason is because the rest is heat. They can't absorb the wavelengths, the infrared wavelengths. They can't absorb all the other light spectrum, but they're very specific to a specific wavelength of light. And the solar heat tubes, they just absorb basically almost everything.
Well, that's changing though, because the solar cells they got now are not the solar cells I had when I was in college, and one of the things one of my studies was solar cell fabrication using silicon-based substrates, So, yeah, but it's so different now. I mean, they even got paint now, which shows as solar cells, and I just kind of glanced through and saw they had some kind of major breakthrough the other day, in which will be able to get even more out of these solar cells. Solar is the way to end up going a part of our needs,
Yeah.
But they're working on getting the dark light solar cells to operate in the dark.
Well, and here's another thing. Texas had a all-time low temperatures, and a lot of people died. The grid failed. If people just had wood stoves, they would have been able to survive. But they froze to death because they didn't have a heat source. So everybody should have a wood stove, and everybody should have. But even if you have a wood stove, you don't have electricity, unless you have a system like this. Then when there's no sun, the solar panels aren't working. At least you have that wood that you can heat your home with, and you have electricity. So where everything else fails, this still won't fail.
Well,
Not only that, but yeah.
Texas is definitely a place you need the home-based backup systems. My daughter lives down there. Keep telling her she should move out, but they just, when this last hurricane, it took out most of the power in Houston, and they had the opposite problem: too much heat, you know, and people died. And last I heard, there's 26 people died from heat.
The cooling capabilities of this is incredible. The pump uses it. Yeah, that's going to be our next innovation is the heat pumping, and we've already got it on the shelf. It's coming. You take that extra heat, you make electricity with it, and then you can cool your house as well.
Well, she's going to get one of those engines or whatever, you know, the ones run on propane, as a backup, as this is the second time they had to suffer through extreme temperatures without no power,
Well, those will definitely work, but I don't know if you're worried about the long-term side or effects of not having. I mean, if you want reliability, this is also the most reliable system because there's 2 bearings that you have to replace on that turbine to fix it. You take 2 end caps off, you take your magnet off, put your new bearing, you take your old bearings out, you put your new bearings in, and then you put the caps back on. You don't even have to disassemble the main part of the turbine or the rotor. So literally anyone can do that. Anyone can do the maintenance to fix the turbine. So you'll start hearing the bearings whine eventually, and then you'll be like, okay, it's time for a new pack of bearings. If I wanted a turbine system to last basically my whole lifetime, I would buy a pack of bearings, right? And then I would have a system that will last a lifetime. Now, growing up with solar systems, using a lot of generators, when there's not enough sun, we've been through like 10 generators already. Not me personally, but like my dad, he's been through me growing up. And you can fix them to a point if you can find the parts at the hardware store, but so a lot of times you can't. So just say this scenario, give a scenario where there's no grid power and you have to fix your own things. A generator is going to be almost impossible unless you have an entire machine shop. But if you have a turbine where the only thing that can go wrong is those bearings go out, just replace them, and then you got another long time to run your turbine with those newer bearings.
Here's a comment. Hey, Mike, my diesel to hybrid conversion is going to take the heat from the engine coolant, as well as the exhaust of the main engine, the 120 volt 43 amp diesel cycle compartment, and propane exhaust. So I think this guy's looking at making
he needs a good turbine. Yeah. In his case, I would use a steel casing. Right now, we're going to be selling aluminum turbines, but we're also thinking about giving an option for stainless steel, which would be more expensive, but also a steel turbine, and it would be perfect for his application as well.
Well, once upon a time, I used to work with bearings. I worked on the space shuttle seats. They were having a bearing problem where the bearings are wearing out, and my boss, he come up with a new type of bearing there they used without those nipples on it, and I could never run them long enough to break them. Yeah.
These bearings that we've got are rated at 60,000 or 70,000 RPM, and we're not even going anywhere close to that. So you have a perfectly balanced rotor, which I've been able to develop which I've been able to do with Tesla balancing patent. Took me a while to develop that and get that working, but got that working, and now I can balance rotors perfectly. So you get a really good balanced rotor, really good bearings. This is going to last a long time.
Well, the other thing is the Bork engine, and actually all aircraft engines, jet aircraft engines, they use a special type of bearing called a triple slip ring. And with that, you can run these high speeds that you need to run on this Tesla turbine, okay? And I don't think you would ever have a bearing problem, to tell you the truth, using that type of a bearing. And like I said, because the speeds you should be reaching with this turbine should be just as great as an aircraft engine. And in the 50s, I don't know if you're familiar, but in the 50s, they were having aircraft fall out of the sky. And what it was, they were just started using jet engines, and it was bearing failure. And that's how they went to visit this guy by the name of Russell Bork, who invented the Bork engine. And he's the actual inventor of the triple slip ring bearing, because like they come up to him and said, your engines run as fast as our jet engine, What do you use to keep from bearing failure? And that's what he showed him. Of course, 3 years after they visited them, they come out with their new invention, the triple slip ring bearing, which was the savior of the day. So you got to watch out for these corporations, because they'll take your ideas and they'll run with them. So
yeah. Well, no one's been able to reproduce, to do this and run with it, probably because we're protected by the patent. But also, it's a very complicated, it's a very difficult thing to do. You have to get everything just right, or you're going to have some pretty poor performance with the Tesla turbine. Once you get everything right, it just runs so beautifully.
Well, I don't put much faith in the patents, because, these corporations will find a way around the patent. Your main protection is between your ears there, and keep a trade secret, And I think you get better protection for that way for your ideas, as a trade secret, as opposed to a patent. And anyway, here's some more comments. Right, yes, black pipe in the sun is a great alternative to PV and is a passive direct way to heat the water, passive solar. So, and this guy who was talking before, in propane exhaust, after exhaust heat exchanged with intake air, this diesel runs hotter. Looking at the gauge, and I reads engine coolant temperature ranges in 140 to 280 with, I don't know what his red is.
Maybe the red is like the temperature color, the color of the exhaust.
Probably red line.
Oh.
So
yeah, as far as if you can get those temperatures higher, I mean, my top, let's see what.
There's the red.
Okay. 280 is a good temperature to run this turbine at. I mean, ideally you'd have it a little bit higher than 280. Like that test, I want to operate about 280 to about 300 or 350. So those solar heat tubes, they can get over 400 degrees, or at least 375.
Yeah.
Some of them say they go up to like 570 degrees in those solar heat tubes. So that's just why instead of using the ambient, instead of using anything else, I would use those. But as far as the diesel generator goes, you could definitely recuperate some heat energy from that, from the diesel generator. There's a lot of power coming out in the form of heat on those diesel generators. So yeah, you could definitely recuperate that. Another thing that you could do is you could heat your thermal reservoir with your generator so that you can heat your house with that heat and also get electricity with the turbine as well with that extra heat.
Well, I hope next year you could come to our conference with your turbines and that, and actually show these people. There's nothing like, grabbing onto something to feel a torque. We can sit here and talk about torques and speeds all day, but it's another thing to actually visualize it and actually maybe grab a Prony brake, and actually feel the power there,
Well, it's so far away is the only problem. You got to haul everything down there,
Well, what you gotta
And
do.
it takes a lot of money.
That takes more planning, I've been doing this conference for so many years on a $0 budget, and people just got, our best speakers are our most creative, and they figure a way to manage it because it's important, I know, like in this day and age, like we're doing a live stream this year, and we'll probably do a live stream next year, But the thing is, we're trying to really build up the in-person, because it's when you can sit down with somebody face to face, sit down and talk to them, you can gauge more accurately, like, this guy blowing smoke or what, and you can put a face to it, to someone when they talk and everything. You really don't do that, on a video. Like I built this one device that's 10 times the input, That goes like 20 amps in, 30 amps out. Incredible stuff. Even blew up an ammeter in my hand, one of those car ammeters. It blew up in my hand. We went to attach that wire, it blew up, and it had so much power in it. But, you don't get to do that on a video. And I wouldn't trust me, especially voltage readings and everything, because power is a tricky thing. You have a lot of energy, which is volts, which is differential, and you have your amps. It's the combination of the two that produces real power.
Yeah, and for instance, my turbine right now, it goes up to like 400 volts on the output when we're up to full speed.
But how many amps?
But the amps, we haven't tested it at full speed yet. Yeah. It could probably, my prediction is about 5,000 watts from my little generator at 35,000 RPM. But now the amps, if you take 35,000, if you take 400 divided by, or if you take 5,000 divided by 400, you get 12 amps. So it's not that many amps, but if you put that through the charge controller or two charge controllers, you could get like 200 amps out of that on the output of your charge controller, but the voltage is also lowered as well. So the wattage is the same, even though we got more amps on the output of the charge controller. That's another cool thing about the Tesla turbine is there's no way to trick. There's no way to trick any. There's no way to trick.
Are we talking AC? Are we talking AC or DC on this wattage and everything? That's the problem, because it's AC in that. You start getting the phase shift and everything else.
Yeah, it gets more complicated to.
And you start to get an RMS voltages as opposed to actual voltages in that. But that's the only real test in my book. It's horsepower, torque, and that's like when I built this.
Or watts, right? Or wattage?
Not wattage, torque. Hook it up to something and have it spin it, And what your output is, that's your real output. That's what is really happening, And
well, also it's really easy to get your watt. You get the horsepower by using DC.
still the only real test I think is horsepower. You know, uh, you can't fake it. You know, and you can't fake a torque. It's either going to turn or it's not. You know,
Yeah.
that's the thing about torque. You know, and voltage is an match. You know, your finger slips, you know, on a button there, and all of a sudden you think you're reading tens of volts. You know, and it's in the volt range, but because it's in the volt range, all of a sudden they expand. You know, blows up. You know what it should be reading because you're on the wrong scale. I've seen that happen. You know, and that's come the torque test. You know, is really the basic test and what they rely on. You know, and like you said, you know, well, if you go to grab on that thing and it throws you over for a loop, you know you got torque. You know, and that's a common.
Yeah.
But who knows? Maybe next year I'll be able to come. You know, maybe we can develop a mini demo or. You know,
Well, we got so much power out of this one. We got more than we need, so we might be downsizing in the size, but none of that's figured out yet. So we're, we'll see.
well, the thing is, you know, at the conference you get to meet, you know, people who are doing a lot of stuff. I think Jeff is listening out there. Jeff Hayes, hey Jeff, I'll be looking for you to get your abstract in after this conference for next year. You know, I think he'll be there again next year.
Oh, Jeff Hayes is here?
He's probably watching you right now. But
oh, that's awesome.
But
I
think he'll be down next year to the conference.
I read his book so many times. I always wanted to meet him.
Well, he's a very skilled speaker too, and he has a wealth of knowledge. And he's been down to that shop in San Diego with those pumps and everything, you know. And and he's met both Jake Purcell and Max Girthy, the other guy. So yeah.
Wow.
Yeah, here you go. Abraham Barker, horsepower is directly convertible to watts. They're essentially equivalent. Yes and no. You know, horsepower is physical mechanical motion. You know, and watts is more of an electrical measurement.
But if you take 200% efficient things, or you got your mechanical, and then you have 100% efficient generator, 100% efficient motor, which we're not saying that that's there or anything, or that exists, but it could probably. But you're going to get, if you put 700, if a certain amount of watts, I think it's 740 watts into that motor, it's going to generate 1 horsepower of torque based on the speed. You know what I mean?
Yeah, but there's a lot of other things too, you know, like this conversion, because if you have horsepower and you want to get to electrical power, you still got to hook it up to a generator and you got some losses. So it's horsepower is directly convertible, but that's, you know, math games, you know, games. And Tesla had a thing about all these math where these people, you know, they start relying on these maths and conversions and everything, and it will lead you down the primrose path, you know. But it's only the physical that is really a matter.
This is website.
But anyway, do you have anything else to say, or is that pretty much it?
That's pretty much it. Other than my Patreon's the best way to see our progress right now. And it's helping me personally a lot, get to be able to spend my time working on this project. And also the patrons will get the first dibs on the turbines when they're finished. So if you want to get in line to purchase a turbine, And if you want to see the progress and the updates happen more frequently, that will be the Patreon.
Well, here's another-
So, for instance, I mean, I would like to publish everything on YouTube, but it takes a lot of time to edit the videos. And so I took a break from YouTube, probably 6 months or over a year. And I finally put an update on YouTube. And I do plan to have more updates on YouTube. But for now, just to have the updates on the project, the most exciting part of the project right now is going to be my Patreon.
And do you have a screen that give your contact information so people can try to get hold of you?
I don't have that actually. Yeah, and like I said, that presentation was an older presentation, and it's unfortunate that that's the one that I used today. But
So what's your email address?
my email address, can I write that in the public chat, or can I write everything in the
Go
public
ahead
chat?
and type it into the comments there. And so
Wait, this is connect.
let's just post a comment.
Yeah, it's having me verify myself on YouTube.
Well, I'll tell you what.
I'll write it to you in a private chat. Maybe you can just comment or message it.
Okay. But anyway, I'd like to reiterate to everybody, don't forget we have a conference coming up. Right now we have our live stream. Our live stream right now is set at $99 for right now. And it's quite the bargain. If you want more information on it, go to our QR code there. That QR code will take you to the live stream information. And let me see if I can find. So as soon as I get the info, I'll be throwing up on the screen here. And next week, I don't know who's going to be on next week at this point.
Yeah, I just wanted to mention Aaron's website as well, because he's my partner. He's been helping with the project a lot. So I just put his website up there, and I got my website and my personal email. I usually don't give it out, but I'll give it out to your audience. And then my Patreon, is at the bottom there. So
Okay, for the I don't think LinkedIn takes comments, so they'll have to check it out on YouTube. But basically, it's notime500@gmail.com. Okay,
yeah,
that's the email, and then the myteslapower.com is your website.
yeah.
Okay, and so if anyone gets a chance, go up there, check out his website. Maybe get a hold of him if you're interested in collaborating with you, or maybe if you're an investor type, get a hold of Jeremiah. Okay?
And then the Patreon is patreon.com/iEnergySupply.
And so go check those out. And Abraham Barker, the live stream could be interesting. I'm sure it will. Because the videos are going to be available to the people who sign up for the live stream forever. Even if you were going in person, which we would prefer you to do, okay, get the live stream. Then that's why I said, be available to you right there at the conference. It's like $99, and the set costs $300 on sale at the conference. So it's a no-brainer. Anyway, like I say, contact us for the conference. I know everyone's going to have a great time at the conference. I guarantee it. If you aren't, then basically, well, come and see me. I'll be there. I want to know why you're unhappy. And $84 a night, you can't beat that with a stick. These rooms are normally $180 a night. So we're getting a huge discount. Plus, we got breakfast thrown in. So you can't beat that, And if you throw in the food at night and a chance to meet the speakers, you can't beat it. So anyway, my number is 520-463-1994. My website's testatech.info, and the information for Jeremiah is notime500 at Gmail is his email, and mytestapower.com is his website. And I imagine you have a link from that to the Patreon site, right?
I got my Patreon on my website. Yeah.
So go
And
up
it's
there.
also in my YouTube videos and all that.
So all you got to remember is mytestapower.com, and you'll be able to find Jeremiah. Thank you for being a guest there. And we'll see you all next
Thank
week.
you everyone for joining.
Yeah. And so I'll be looking forward to seeing you next week at my